Okay, so before we start the first unit of mathematical induction, I gave you a sheet of questions. It's on the assignment, and let's just go over some of the stuff. So 1, 2, 3, 4. This is stuff you're going to need to know for when you do mathematical induction. You'll see there's a reason I asked these questions. So 1, 2, 3, 4 are consecutive numbers, integers. What is the truth about the sum of any two consecutive numbers? So what do you think? So how about 1 plus 2 is 3. How about 5 plus 6? That's 11. How about 30 plus 31? It's 61. Well, they're all odd. And so n plus 1 is always odd. Let's see. What is true about the product of any two consecutive numbers? So let's see, 8 times 9, 72. And, I don't know, 15 times 16 is, what is 16? It's 240, right? And how about 30 times 31? What is that? That's 930, right? Well, these are always all even. So n times n plus 1 is always even. What about the product of any three consecutive numbers? Let's take a look at this one. The product of 3. So I don't know, 1 times 2 times 3 equals 6. How about 7 times 8 times 9? What is it? 63 times 7. 1, bring up 2. 44, 441. How about 15 times 16 times 17? Well, the one thing we're gonna need is that I'm not really sure what this is. Hey Siri, 15 times 16 times 17.
15 times 16 times 17 is 4,080.
Well, it turns out that all of the product is always divisible by 3 and by 6. So n times n plus 1 times n plus 2 is always divisible by 3 and 6, right? Because at some point you have a multiple of 2 and you have a multiple of 3. So once again, n plus 1 plus n plus 2, or any three consecutive numbers is going to be divisible by 3. And also you have that 2 in there, so it's also divisible by 6. Little things you need to know. You'll see why I'm saying this stuff. Let's move on. If a number is even, so if n is even, then we can say it's equal to 2k. So what's the next even number after 2k? Well, the next even number is 2k plus 2. Let's see. If a number is odd, if n is odd, then it can be expressed as 2k minus 1. So what's the next odd? So what's the next odd number? So it's 2k minus 1 plus 2, which is 2k plus 1. So for example, this would be, so the third, let's see. Yeah, the idea is that we have to go up 2. So if an odd number is 2k minus 1, the next one is 2k plus 2k plus 1. What's the one before this? Well, that would be 2k minus 3. Let's see. What is always true about k squared? Well, k squared is always greater than or equal to 0. What's true about a minus b squared? Plus c, if c is greater than 0. Well, we know that this is positive. It could be 0, but if this is greater than 0, that means a minus b squared plus c is always greater than 0. When is 7n minus 1 positive? when n is greater than 3. What does it mean when one says that A is divisible by B? And you're saying this, what do we need to know these for? Well, you'll see. You're going to see. So what does it mean? A is divisible by B. That's the notation for A is divisible by B. And it means basically that A is equal to some B times K. That's the idea. So we say that 8 is divisible by 2 because 8 is equal to 2 times 4. Or we say that, I don't know, 18 is divisible by 3 because 18 is equal to 3 times 6. When is a number divisible by 6? A number A is divisible by 6 if A is divisible by 2 and A is divisible by 3. So we could write A is equal to like 2n and A is equal to 3n. That's the idea of divisibility rules. That's the idea that if it's divisible by 6, it's divisible by 2 and by 3. Last one. Let's think about this for a second. We have A is equal to bx plus cy. We're told that A is divisible by 3 and bx is divisible by 3. So how do we prove that cy is divisible by 3? It seems a little advanced, but you kind of know what to do. Let's think about this. Well, if A is divisible by 3, that means that A is equal to 3k. And if bx is divisible by 3, then we know that bx is equal to 3l, right? So we have 3k is equal to 3l plus cy, right? Therefore, cy is equal to 3k minus 3l. Well, you can visually see what's going on here. This is equal to 3 times k minus l, which means cy is divisible by 3. And this is kind of an important thing that, so just, look at that and you'll see, trust me, it's going to show up. Now, put this in the back of your mind for a second, and let's move on to the first unit. We're going to stay with the Hess book for mathematical inductions for a little bit, but the first unit is called conjectures, and this is very quickly. A conjecture is simply, it's just a statement that you believe to be true, based on like a little evidence. So a conjecture is a math statement you believe to be true, kind of based on weak evidence. Now, is it true? And you might think it's true, but we have to prove it. It must be proven. So it must be proven. So, but today we're not going to prove it. This lesson we're not proving it. We're just making some conjectures. So, for example, let's start with 1. Let's start with the first. What's the first even number? So the first even number is 2. 2 times 1. What's the second even number? You're like, okay, well, it's 2 times 2. What's the third? 2 times 2. So your conjecture is that the nth positive even number is 2n. That's your conjecture, you think. Because you have a couple of examples, we have to prove it. So today, once again, you're just going to be looking for a conjecture. Here's something more interesting. Here's something interesting, a very interesting conjecture. What is the first odd number? It's 1, but let's add it up. We have 1. The first 2 odd numbers, 1 plus 3, that's 4. How about the first 3 odd numbers? 1 plus 3 plus 5, that's 9. This is the symbol for sigma. I should be more clear. Let's try another one. How about the first 4 odd numbers? 1 plus 3 plus 5 plus 7, that's 6. So you might want to come up with a conjecture. The conjecture is that the sum of the first n odd numbers is n squared. And this unit, I'm gonna show you a method for actually figuring out how to prove that to be true. The last conjecture, right? And so the conjecture. So what's the the sum of the first 10 numbers, odd numbers? So we have 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What does that equal? Well, the claim is that it's 10 squared. Does it equal 100? Well, yeah, that works actually, right? Because this is 20, 20, 20, 20, and 20. That's 100. It seems to work. But that's not good enough because in math, we need to know if it goes out to the infinity. And we have a method for that. Last cute little thing. Let's see, can I do it? Let's see, ready? Let me erase this. The last conjecture that I'm going to prove, a famous conjecture that we know is that the sum of the first n positive integers is n over 2 times 1 plus n. Right? So for example, 1 plus 2 plus 3 plus 4 plus 5. We know it's 5 over 2 times 1 plus 5, which is 15. And it works. And I told you it works, but we never really proved it. And so I'm gonna show you how to prove this. The last one is, let's take a look at this. Here's the last one. 1 divided by 1 times 2 is 1/2. And 1 over 1 times 2 plus 1 over 2 times 3 is equal to 1/2 plus 1/6, which ends up being 2/3. Coincidence? Maybe. I don't have enough. It looks like, I might want to make my conjecture, but I'm going to wait. Let me do a couple of more examples. How about 1 over 1 times 2 plus 1 over 2 times 3 times 1 over 3 times 4? That's 1/2 plus 1/6 plus 1/12. That ends up being 3/4. Should we do it again to see, kind of right? Here's our examples. Let's do another one. Let's see another one. Because this is where it comes from. Let's see. 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over 4 times 5 equals, we know it's 3/4 plus 1/20. The claim is that this is 4/5. That's the conjecture I'm coming up with. Does it work for this one? Let's see. 60 plus 4 over 24. Oh, sorry, over 80. Whoops. Let's see. 64 over 80 divided by 16. We get 4 over 5. I think we have a conjecture here. What's our conjecture? What is our conjecture? Our conjecture, is the sum starting from n equal 1 up to, a k of 1 over n times n plus 1 is equal to n over n plus 1. And I think, we did sigma notation. Once again, they start at 1, 1, 2, then do 2, 2, 3, go up to the k. Yeah, we did this with sigma, and this is the conjecture. This is the claim. We're going to be proving this. So what I'd like to do is you look at the first unit in the Hess book for mathematical inductions and work on the conjectures. That's it.